Okay, so we are going to continue from where we stopped, but a form of recap for last week class that we did. Even though at the end of last week we tried to give a kind of a little project for us to do, and we believe most of us have done the project already. Uh, so can we focus so that we listen? Uh, where did we stop? We've done converting from one numeric type to another. Have we done that? Converting one number to another? Okay. If I could remember, we talk about the Boolean, using Boolean in while loops, right? We talk about Boolean data type. And under Boolean data type, we said they are used in different places, right? Um, we said one, it can be used in if statement. You can use Boolean in if statement. I would say Boolean can also be used in while loops. I will also say Boolean can also be used in comparison operators, like in comparison, comparing. So you can compare two items and it give result of what Boolean. And that's why you created a variable X and you install the value of 10 in X. You also create a variable Y and you store the value of 15 inside. So when comparing, you say if X, print X greater than Y, is going to be false because X have a value of 10, Y have a value of what, 15. And truly, X is not greater than Y, so the result will be what, false. So you can also have, we use Boolean operators in comparison operators. And for you to take notes, you know, when you look at some of these figures, they are very useful in making decision making. That's in decision making comparison operators. So when you talk about if is for decision, while controlling loops is while, then comparison values is greater than, less than, equal to, and not equal to. Now, if you look at the symbol for greater than, equal to, and not equal to, you find out that Python only recognizes those symbols for those comparison operators. Kozika keshi kusanya. Okay. Now, if you look at this value, if you could remember greater than, less than, this is sign for equal to, and this sign is what, not equal to. Remember, you said this is called what in English? This sign is what? Exclamation mark with equal sign is in fact to not equal to. So there is what's called number data type, and we started last week, if you remember. And we say Python has three types of what, numbers. We have the integer, which has to do with whole numbers, numbers without decimal points. We have the floats, which are numbers with what decimal points. Then we have complex number. And we say complex numbers are real number and imaginary number. And we say they are usually written as A plus B, J. And I said that any number that have a mixture with letter, especially when it has J, that is called a complex number in Python. Then we said that don't put more emphasis on the complex numbers because you might not necessarily use them in future, but it's just for you to have an idea about what is what a complex number. Now, as you all know, Python is smart. Since it is smart than other programming language, unlike other programming language that you need to specify specifically on what type of number you are referring to when programming. In Python, you don't need to do that. By the nature of the number, Python will know if it's an integer, float, or a complex number. For example, you don't need to tell the type of data when you insert in Python. It will automatically figure out whether a number is an integer, a float, or a complex number based on how it is written. We are not going to do this in detail, but we are just going to say it in passing by, just to pass you, just for you to have the idea. But it's not something that you must understand it clearly because you might not just use them. Like special integer format in Python, we have what's called octal. And so those of you that are good in maths, you know that octal are basically 4 base 8. You look at how it starts. Then it is used less often, mostly in programming for specific tasks. So I said you don't need to really bother yourself about this. But the integer, whole numbers are positive or negative or 0. So 0 alone is an integer. -1 is an integer, -30 is an integer, while 40 is also an integer, whether a negative or positive whole numbers. Now, integer can be very large, only limited by your computer's memory. Example, you can write multiple numbers as long as they are whole numbers, they are integer. For example, you see 44, 4,500 minus 320, and you can see this is a very large number, 9, 6, 7, 8, up to here, all is integer. So when they ask what is this integer, as long as it doesn't have what a decimal point. So these are integers. Then there is what called hexadecimal, base 16. So these are things that you might not necessarily need them, but just know that they are mostly used often in computing, especially like colors, memory address, and so on. And those of you that did computer vision, you find that most of these things, you use them in computer vision, where you try to make an image in computer or something like that. But then it's not something that you should bother yourself. Okay? We have binary. Binary, as you all know, is base 2. And it only uses 0 and 1, and that's the major language of computer, 0 and 1. So we can also look at converting integer to other bases. You can convert integer to other bases. You can convert a normal integer to octal, hexadecimal, binary, using what we call a built-in function. So we will come to know that Python have what's called a built-in function that they are programmed inside the Python. So when we read, before you finish your the beginner level, you'll be able to start calling some inbuilt function from Python. For example, you want to do math. So you call, it's an inbuilt function, you call math. So all the formula you want to do, Python will be aware of it. You just say import.py. But it's just that sometimes you need to update the environment you are using. Like maybe the Tony, if it is new, you have not updated it. That is the way you have to update it so that the package that you are going to use, you should upload it first. so that you know that you can call it and continue using it. So if you want to convert, it's just for you to use this function. If you use this, it means you are converting. If you say oct, you are converting to octal string. If you say hex, open bracket and close bracket, you are converting to hexadecimal. If you say bin, that's binary, open bracket and close bracket, you're converting to binary string. So just put the number inside this bracket, it will convert to that number. Now, for example, if you create a variable, num and you name it num, you create a variable num, num, and you store the value of 45 in the variable, right? And this is 45. This 45, is it an integer or a float? I don't say anything. Professor, the integer, sorry, this num is a variable, right? Is it a variable name? So what is the value inside the variable? 45. So that 45, what kind of data is it? What kind of data type? Huh? It's integer. Thank you. So now, since it is an integer, and if you want to convert it to maybe octal, hexadecimal, or binary, look at the formula you're going to use. It's a function. If you call oct, it stands for octal. Open bracket, close bracket. If you open the bracket, just write the variable name inside. It will automatically convert the 45 to octal. Now, hexadecimal is hex, open bracket, you write num. It will automatically convert hexadecimal, this integer to what? Hexadecimal. Also, binary for bin, bin. If you open the bracket and write num, it will automatically convert it. So you can do that now in 1 minute so that we'll continue. Just 1 minute you have because we didn't have time. So if you come, the first thing you should do is to make sure your 20 is ready. Not that when they say we should start something, that's when you start making your 20 to be. Create a variable num, put 45 and change all of them. Until you're fasting here. Sorry, man. Where's your phone now? Why are you right? Huh? Yeah, print it. Let's. Are you still around? Wait. I thought I have to remove it from the program. Okay. Okay, fine. So you can see what it gave you, right? So even though you don't understand how it is, let's continue. It has converted it, right? Now, if you see the value, the output is different because the first one is what? It converted to octal, while the second one converted to hexadecimal, and the third one converted to what? To binary. I would say binary is what? Zeros and what? One. So the binary digit was what? What's the binary there?
0 1 0 1 1 0.
So a hen. Can I get me? Sai ka dan daga kusa da wajen lokaci kenan don ba kallo online. What what you are going to do, it means that that binary value it gave you, it means 45 in computer. Computer have to change it to that number of binary before computer will understand that it is 45. Kungani? It means that that 45, computer have to change to 01, 01 to that is 45 for computer language. Before computer will not give you the output that okay, it is 45. So you see how many times 45 have to be permuted before it knows that it is what 45. So if you put another number, maybe the zeros will change to another something like that. Number of, but someone might ask, oh, if computer has to do all this change, why will you see our output? Why will it be very fast? Yes, because the timing, I think they use now. Yes, the computer don't use seconds. Its own timing is different. I've forgotten the. It's very fast. It changes, but it does all those things, and it because there is what to call syntax analysis and other things in computer. So there are a lot of processes that computer follow, and each programming language has its own process. For example, in Python can be a compiler and what an interpreter at the same time. An interpreter follow code by code. A compiler will allow you to finish all your program before it runs. Before it runs. So C++ is a compiler. You have to finish everything there at once. It will. But Python have two characteristics. It's both a compiler at the same time interpreter because it do both. Now, what you should take note for integers: one, they are whole numbers, no decimals. Two, it can be positive, negative, or zero. Python can handle very large integers automatically. No matter how large number it is, Python will do. Now you can write numbers in decimal, octal, hexadecimal, or binary. You can convert integer to other bases easily with octal, hex, and binary. But mind you, if you write octal in full, it will show error. If it is octal, it has to be oct, OCT, open bracket, close bracket. If it is hexadecimal, it has to be HEX. If you write it in full, but that could answer, it will not going to be answer. Then binary is bin, BIN. Then floating point numbers. Now there is something I want to call your attention. If you observe, since when we start this class, we used to call floating integer before we reach code. But here, we have reached here, truly reach here. It means that all those while, if you don't understand those things that are saying, here you need to understand, because once we pass you will not see it again. Just like when we used to call while loops, if we've not still reached, we are just saying it so that you get familiar. Once we've reached, that is why you will not see them again. Okay, so meaning that those of you that are not following at this stage, you must know what is what an integer, because we've passed integer now. So there is no excuse for you to say you don't know what is an integer again. Then floating point numbers. A float is a number that has a decimal point. It is used when a number is not a whole number. Now, you can see a normal float example. For example, when you have 0.50 for 2.50, even though you have 100,000 point something, then 2.5, all this, no matter how large the number is, as long as it has a decimal number, it is what? A float. Take note. Now, these numbers are float because it has a dot. So either 0 point something or 5 point something, either whole number 0.0 or 0 point is still what? A float. And that's the reason why if you convert a float to an integer, yes, float have negative or positive. When you have minus 3.0 is a float. 3.0, so float can be negative or positive as long as it has what? A decimal point. Then there is one thing again. The same way we can convert hectal, octal, this, you can also convert float to integer, integer to float using the same thing. Int, open bracket, put a number, it will take you to integer. It will take you to whole number, integer. If you say float, open bracket, put the number, it will convert it to this thing, float. So that is it.
So what is the abbreviation for plus?
No, float is float, with abbreviation. But integer is int. So can we continue? So if you have a whole number and you want to change it to float, in say maybe float open bracket 45, it will not say 4.5, it will say 45.0, it will just add 0 for you. But if you have 45.30, 45 point, okay, let's say maybe you have 9.7. I normally in mathematics, it has to change it to the nearest whole number. 9.7, I is supposed to just change it to what? Since it is more than 5, it should be 10, But if you change 9.7 and you want to, you say int 9.7 to change it to float, Python will just take the first whole number and forget about it. It will not, it will just say 9. It will not round it up. Are we together? So I don't need to be doing this example because already we've done it. It's just a recap we are doing, right? Okay. Now, why do we need floats in Python? Now, we use float when we need money values. 50.75, you can say 2.5 this because you need to, if without decimal point, probably you cannot divide equal numbers the way it should be. But some people might have 215 error, 2.5, 3, and so on to know how many divisions. Then you will use it for measurement again. For example, 3.5 meters, 5 point something like that. Then for temperature, all this temperature at 6.6 degree. Then division result. When you say 5 divide by 2, you get 2.5. And you have a float with what 2.5 times become what a float, right? Yeah. So now if you have 2 persons and you have 5 items to divide to them, when you do 5 divided by 2, you know how many each will get, right? So that's one of this thing. So now not all divisions that the output will become what a float. It's only when it has what decimal number, when it comes with a point. If it is a whole number, it's not a float. For example, 5 divided by 10 divided by 5 will be what? Now 2, you see, it's whole number. Now there is what called scientific notation here too. Don't bother yourself, just have the information on these things. Not, you might not even use it in future. Scientific notation using E, it can be capital E or small e. Once you see E is included in a number, it's called a scientific notation, whether capital or small. Here, Python recognize it as E. It's not case sensitive here. Either capital or small letter. As long as it's mixed with number, it's become a scientific notation. Sometimes numbers are very big, very small. Instead of writing many zeros, Python uses E. When some call a calculator, sometimes when you do this, you just see they will just write it to show it. Now, the letter E means what? multiplied by 10 raised power of something. For example, you say 3.5 E5. This means 3.5 times 10 raised power of 5. You understand, cool? So that E here, it means 3.5. That E automatic, 3.5 E5 here, automatic Python knows that is what 3.5, then there is times here. Then this E will be changed to a 10 raised power. So meaning that this E is represented by 10 and raised power, while this times automatically there is times there. Yeah, then it will be 3.5 times 10 raised power 5. So whenever you see the E, just know that it's 10 raised power of something. Now, and you know, when they say raised power of something, you have to times that thing times the number of raised power of something. For example, that 10 raised power of 5 is just the same as saying 10 times 10 times 10 times 10 up to 5 times, right? Not 10 times 5, but 10 times 10 times 100. And which is going to be 100,000 Kena. So it will be 3.5 times 100,000. Just saying 3.5 times 100,000. So meaning that this 5 will help you to know is raised power of how many of what. In that answer 3.5 E2, you know that it's raised power of 2. If it is E1, raised power of 1. So if you do 3.5 times 100,000, it's going to be what? 35,000.0. So if you have 35,000.0, Auntie, what's your name? I forgot your name. This now that you have this result, 3.5 times 100,000, it gives you 350,000. 350,000.5. Now this 350,000.5, is it a complex number or an integer? Which one? Yeah? This one become a complex data type? Why did you say so? It's an integer? How come? Because an integer is a whole number, but this is not an integer because it has points. Once it has a point, it becomes what? A float. So when the data type, when they ask what data type here, it becomes what? A float. But you can only say it's a complex number when you see a letter, especially J in Python, then it becomes a complex number probably. And remember we said that J is just the same as what? Square root -1. But don't bother yourself about the complex number and even this just have the idea. And we should just pass since you have the idea here. So you all know that float always have a decimal point. Now scientific notation uses E, either capital or what? Small. Now? Hey. On your keyboard, yes, somebody have answered, so I don't need to do it. So let's continue. On your keyboard, when the key name, which key? Number 6. So you use your number 6. Keyboard number 6. Okay. Now, a complex number is a number that has two parts. Real part and normal number. Sorry, real part. That's when they say real part, it means normal number. Come on, ache 2, 5, or -3 is real number. They're imaginary part. So meaning that a complex number have a real part and imaginary number. The imaginary part, imaginary number, she may number with J. It look like this: A plus BJ. Now A is a real number. That A can be 5. B is what? A number. Then J is imaginary part. A is not. No, they use it here as an example. A here is referring to a value, which can be common sketch. Common sketch. A just like formula I. if you A to represent a number, this thing. But the J there, that's the main thing that is there. Now in Python, J means square root of minus 1. Now, for example, if you create a variable ABC, if you create a variable ABC, and inside ABC you have 2 plus 4J, then you also create another variable XYZ and you have 1 minus 2J, and you say ABC XYZ is equals to what? ABC plus XYZ. You want to add this ABC with what? XYZ. So if you say print ABC XYZ, meaning you create a new variable and you store these two variables inside, right? And if you want to print it, you call this. When you call it, it means that you call ABC plus XYZ kenan. Are we together? Then the output will be 3 plus 2J. Don't worry, don't do it. Let's pass there. It's just for you to just have the idea. Now what happened is that we add real part together, we add imaginary part together. Real part is what? And now your answer is here. 2 plus 1, which is 3. Then imaginary part is the 4J minus 2J, which is what? 2J. So the answer becomes 3 plus 2J. So because you know ABC is 2 plus 4, then XYZ is 1 minus 2. Right? So 2 plus 1 is what? 3. Then 4 minus 2 is 2J. So meaning that, there is one thing I did not tell you again. When we are going to start arithmetic operation in Python, the law of BODMAS applies. So it follows exactly how BODMAS works. So the reason why the answer is 3 plus 2, because it adds the first one, that's 4 and 1, then it now minus 4 minus